So to start things off, I have an object merge that has the in-between sections, and I'm going to turn this into a volume. So VDB from polygons. Set that to a fog VDB. And for the fog, we don't need too much resolution, so 0.1 is probably just fine. And then we'll just scatter some points. For the points, let's start off with a low number, and then we'll crank this up eventually. So 1,000 is fine, and let's also create some geometry to put on those points. So for this, we actually already have some rocks that we use to Boolean things out. It makes sense to just go up here and to copy these guys. So let's just copy literally all this, Control C, bring it down here, paste that in, and then once we have our rocks right there, we can then use a copy to points. Again, copy to points is pretty sweet because we can use the variant attributes. So there's variant, connectivity, that is variant. And then let's also take an attribute, randomize, and let's randomly create a variant attribute here as well. So variant. And for this particular thing, if you want to turn that into an integer, you actually need to use a different node than this because the attribute randomize will always give you a float. So even if we say uniform discrete, still going to be a float attribute, and it's not going to like that. So I take all that back. We're going to use a point wrangle. And we'll basically just say, hey, I at variant is equal to the random function, and we're going to use ptnum as the seed. And then that's going to be a fit 0, 1, and then that's the 0 to 1 value. We want to now fit that between 0 and, let's say, 9. I actually don't know how many variants we have here, so let's figure that out real fast. On this connectivity, we have a maximum of 4 variants. So we need to have the same thing over here. If we say 4, though, our maximum variant value is going to be 3. So we need to go 1 more, and now we have 0 to 4. Okay, so we take these two guys. Remember to also say pack an instance. It's very important. And I believe that should leave us with a bunch of rocks. Awesome. Well, these rocks are pretty sweet, but we need to also randomize some of these attributes. So, attribute randomize. Let's start off with the normal. So, N for normal, inside sphere. That gives us full 360 randomness for that normal. Let's also use another attribute randomize for the p-scale. Or actually, before the p-scale, let's use scale. If you don't know this, this is pretty awesome. Scale will allow you to scale instances non-uniformly. So that lets you stretch out these rocks in different amounts, which is really cool. So on that minimum value, let's say 0.25 is the minimum for X, Y, and Z, and the max is going to be stretched out all the way to 3. So that way, even though we only have 4 rocks, we can get the look of many different rocks just by stretching them out a bit. Okay, once we have that, point wrangle, and now we're going to take care of p-scale. But I'm using a wrangle here because I also want to associate this with a ramp. So let's say that f at p-scale is going to equal a ramp. And for this ramp, we're going to call this our p-scale ramp. We're going to start off by, first of all, creating a random value for p-scale based on the point ID. So let's say float, this is a float variable. We'll say ran p-scale right here, random at ptnum. And then for this ramp here, we'll say the rand p-scale. And let's see what that does. Okay, so we have random p scales for each individual piece. Again, the reason why I did this right here was to give this ramp something to get it started with. So channel ramp, we call this p scale ramp, random p scale value for every single piece. Now, we want to multiply this times something to give ourselves an overall scale. So we'll multiply this times our own parameter here, and we'll call this our p scale. And now we can take everything and generally change the size while still keeping things, the distribution right here on the ramp. So let's say that as a minimum p scale, I never want this to go to 0. Let's give ourselves something maybe right around there with that. And if we want to make this bigger, we can do that. And let's just say that the distribution is mostly smaller pieces, and then we just have it go up really quickly for some of these big pieces. So let's say that we end up with something like this right there, as far as the distribution goes. Now, if we turn up the scatter here by a couple zeros, that'll give us a real idea of what this might look like when this goes to eventually render. Maybe that's actually a bit too much. Let's turn this down by a 0. Now we can really see what that distribution's doing. And again, we want to mostly have small pieces and just have it be a little bit more unlikely to have a big piece. So maybe somewhere right around there is a good distribution of sizes. And then we can just take our p scale down a little bit, and we end up with that. Okay, sweet. So that's going to be an excellent start to these instance pieces. In the next video, let's talk about activation.